All right, good morning, good afternoon, good evening, whatever time it is, whenever you are watching this video. Today, we are going to tackle solving quadratic equations. We're just going to look at the factoring side of it. First of all, a quadratic equation, all we're doing is we are adding one more term to the linear equations that we have been solving. This term will be a squared term, so it will be raised to the second power on your variable. In order for factoring to take place, we do have a very important property that we need. It is called the zero product property. The zero product property says if the product is zero, then at least one of its factors has to be zero. So in other words, if I have two things being multiplied together, I'm just going to say A and B. In order for that to equal zero, what has to happen is A has to equal zero or B has to equal zero. This is a very unique property just for 0. It doesn't work for 7, it doesn't work for 10, it doesn't work for negative 13. All right, if there's a 7 over here, there's a lot of ways I can multiply things to get 7. All right, but if it's a 0, one of these factors has to be 0. So we'll be using that today whenever we factor. So example 1a, we're going to solve by factoring. Okay, so what I want to do is I want to first realize that every trinomial will factor into two binomials. So in this case, everything on the left side of this equal sign will factor into two smaller binomials. And the way I get those binomials is I break apart this u squared that's up front. So I'm going to break it apart as u and u. And then I want to look at my last terms, negative 24. I want to think off to the side over here, what are some factors of negative 24 that add up to give me negative 2? And so if I run through the factors in my head, I realize that if I add negative 6 and positive 4, that gives me negative 2. And that's exactly what I want to put on the tail end of each of these binomials. I've got it factored now. I want to go ahead and solve it all the way. So zero product property says that if it's equal to 0, one of these factors in parentheses must equal 0, at least one of them. So my final answer, I add 6 to both sides. I get u equals 6, or u could equal negative 4. Part B on this side, I see that it's not in that nice form that I wanted for a quadratic equation. For a quadratic equation, I want it so that 0 is on one side and all my terms are on the other. So I'm kind of picky myself with what side I put the 0 on. I love the 0 on the right side. However, even more so, I love to make it so that whatever term has the x squared in it, I want to keep it positive. So instead of moving everything to the left to make it look like problem 1a over here, I'm going to actually just subtract 11x from both sides. And so that's going to give me a 0 on this side. And I'm going to sandwich that 11x right here in the middle. So it's just kind of the flip-flop of the problem I just worked. Now, unfortunately on this one, I don't have the luxury of finding two factors of 12 that add up to give me negative 11 because of this 2 right here. So my first thing I'm going to look for is saying, man, can I get it so there's a 1 in front of this x squared like I had in problem 1a where it worked out so well. So if I can pull a 2 off this right side, I definitely want to. But a 2 won't come out of this 11 very well. So I'm going to have to use something that is known as guess and check. And so if again, I want to break apart that 2x squared. And most of the time you're going to break it up as evenly as possible if there's more than one way to break up 2x squared. For instance, if you have 4x squared, we could do 2x and 2x or 4x and x. Normally you want to do it evenly, depending on your numbers. Now what I have to do this time is I actually have to use a guess and check. So I'm going to I still want to get these factors of 12. And I'm going to cheat a little bit. I see that there's a negative sign in front of this 11. So I'm willing to bet I need two negative factors of positive 12. So I'm going to purposely miss this one up front. I'm going to say, well, I like -2 and -6. So whenever I plug in -2 and -6 right here, I have to now go through and check my answer. And the way that I check it is I just go ahead and make a smiley face out of my last step. You guys see the face with here with the 2 eyes, and then the nose and the mouth. And the reason I make that is because on my check, what I'm going to do is I'm going to multiply the 2 numbers that are at the end of my nose, -2x, and I'm going to add the 2 numbers, the 2 terms that are at the ends of my mouth. In this case, that's going to be -12x. And so whenever I add those, I get -14x. I overshot my -11x. I really want it to match right there in the middle. So I'm going to have to go back and I have to erase all this. Okay? This is part of the guess and check. So the -6 and the -2 did not work. Okay, let me try to get a better guess so we can just get to the answer. Let's see. I think if I put a +4 right here, and I'm sorry, rewind. Sorry, let's put a -3 right here. Oh, maybe I just need to start guessing more. Here we go. There's a -4 and a -3. That I think will work, but I'm still going to double check it with my nose and my mouth right here. And so my nose gives me -3x, and then my mouth gives me -8x. Whenever I combine those terms, I get the -11x that I need right there in the middle. So now I have it factored correctly. Okay, so I can do 2x -3 equals 0. I can do x -4 equals 0. Solving that all the way down, I get x equals 3/2 and x equals +4. And feel free to check your answer. You can plug in either one of these numbers back in for x, and it should give me a true statement. All right, C and D, I'm going to let you try. I'm going to pause the video for a second. You try to work these out. And then once you're done, hit play and see if your answers match mine. And here's the answers I got. All right, lastly, there are a couple different special factoring properties that we can use on these. You should have learned in Algebra 2. All of those are fair game, but here's some basic ones that you might see in the homework. For instance, this one on the left, whenever I see it, problem 1E, I look at it and I'm like, man, I think I can, there's something called difference of 2 squares. So even though I don't have a middle term in here, I can still take the 16b squared, and what I do on difference of 2 squares is I take the square root of it and I put it in the first position on each binomial. The same thing with the 25. I just take the square root of it, 5 and 5. I make one of these plus, I make one of them negative, and then it is actually going to be factored. Okay? You can go back and FOIL what you got to make sure that it's factored correct, but I'm pretty sure I did that correct. So I get v equals -5/4 and v equals +5/4. Now, I can do the same thing over here on problem F. I can go ahead and get it in this form. But I look at it and the 28 is not a perfect square. Neither is a 7. That's why I always want to look for that greatest common factor that I can divide off on these equations. So if I divide everything by 7, now I've got that perfect square. Let me show you an easier way to work this though. Right? Keep in mind you only have one variable right here. So if I come right out of the gate and divide both sides by 7, I get v squared equals 4. I take the square root of both sides, boom, I'm at the right answer, plus or minus 2. I still could have got there working it this way, but man, it's a lot more writing I have to do. So both of them equal to 0, I get v equals -2 and v equals +2. I assure you both ways will get you full credit in my class as long as we're getting that right answer. Okay. All right. Good luck with the homework.